Thank you, Kunal. Hi, everyone. I'm Ankur Kotwal. I'm a developer advocate on the Developer Products Group team. And today, what I want to talk to you about is the 3 C's framework that Kunal just introduced. We feel that the 3 C's framework helps to categorize a range of technical challenges that you will find in this market. And what I want to share with you are ways that you can address those challenges. So let's start off by talking about connectivity. The first thing to keep in mind is that not all networks are the same. You can have users on a 4G network that have 2G-like speeds. You can have users that are on broadband networks, on Wi-Fi networks, that also have very slow speeds. And in fact, that same user on a 4G network with 2G-like connectivity can travel 2 blocks that way and suddenly get 4G connectivity. So what you want to do is not make an assumption about the quality of the network based on its network type, but you want to be continually conscious of the quality of the network that your app is experiencing. So to keep our apps responsive and useful, we want to do things like prioritize our data requests. Pull down text from your servers first, because you can present that information to your users and have your app usable whilst the rest of your images load. To show you an example, you can see here with this app, the text loaded up nice and early, and the images started to load up over time. We didn't fetch all the images ahead of time either, so as we scrolled down the list, we pulled more images down. In fact, if you start to think about it, you realize that as you start to address unreliable networks, you start thinking more towards, well, how is my offline experience? Because they are, in some ways, similar. What we want to start to do is actually optimize our apps for useful offline experiences. We want to start caching our data where it's appropriate. So when we fetch an image from our servers, we want to store that locally. And next time when we need to present that image, we want to present it from our local cache. There are libraries that can help you with this. Picasso and Glide. These are open source libraries. And I recommend that you use them because they will fetch your URLs. They will also cache it. They will manage it for you. And actually, they can help you downsample those images. And we'll talk about that in a minute. The material design guidelines actually recommend that when you have space for images and they haven't loaded yet, that you shouldn't leave that with just empty space. You should use flat colors as placeholder images. And we have a library called Palette in the Android Design Support Library that helps you generate those colors depending on the imagery that you're seeing. Now, this app here is working in airplane mode. And as you may have noticed, as we scrolled through the app, it was totally usable. And that's because it was designed with offline in mind. So I recommend that you look at your own apps and see how they work offline. And the way that you can do this is just to go to your device, put it in airplane mode, and test it out. It's a fairly straightforward way, and you may be surprised at the results. So that's a little bit about connectivity. Let's talk about compatibility. One of the strengths of the Android ecosystem is that developers and users have a choice of device. Some users like small screens, some users like big screens. Some users like great cameras, other users like more storage. So this means that as developers, we shouldn't make assumptions, or rather, we should optimize our apps to be flexible. I'm going to talk about that. Let's start with screen sizes. All of our layouts should be declared in density-independent pixels, or DIPs. Developers will know these as DIPs. A density-independent pixel is basically a physical size for your layouts. So if you have a 64 by 64 DIP image, that image is physically going to be the same size on a 3-inch phone or a 5-inch phone. And that helps our apps be responsive and scale to different device sizes. Google also provides the app compat and design support libraries that include a set of predefined components that you can use. These components actually embrace the material design guidelines that Francis mentioned earlier. But best of all, these components are backward compatible to Android 2.1. So if you have users on older devices, on older versions of Android, they can still have a modern user experience, a modern look and feel from your app today. In India, everyone speaks so many different languages. You can go to one state and have a different set of languages to another state. And so it's really important that as developers and content creators, we create content in languages that our users understand and can read. To help with this effort, Google provides the Noto font that includes support for 10 Indic languages and growing. And the great thing about this font is it's designed to read really well, but it's also designed to scale really well. It's really readable on a watch. It's just as legible on a phone, and it scales beautifully to big screens as well. As we go to build our layouts, we also want to test them out. So in Android Studio, you can actually preview all screen sizes. So as you code your layouts, you can see how that layout looks in real time on a set of devices. And in fact, Francis mentioned earlier that we've recently announced Android Studio 2.0. It has a brand new emulator. Now, I know many developers have given us feedback about our emulator before, so I'm really excited to tell you that our new emulators are faster than physical devices. So when it comes to supporting multiple screen sizes, there's no excuse for having a different set of emulator configurations set up for all the types of device sizes you think your users have. Instant Run makes it even better. Instant Run is a feature of Android Studio which will deploy changes that you make to your code in just a few seconds. And the reason it works so fast is that rather than package up your whole APK and deploy it, it can connect to the app that you're debugging on an emulator or a physical device and just send the changes across. So it's really smart and really, really fast. Helps you make rapid changes and see them across various screen sizes. But I want to switch gears now and talk about memory. Because memory is also another differentiating factor across devices. And as developers, we should be conscious of how much memory is available to our app at runtime. We have APIs like isLowRamDevice, getMemoryClass. And these APIs help give us indications of how much memory we have to play with. So it's really important that we actually request these values and change our behavior accordingly. As we run on different sized devices, we should also be conscious of the images that we use, because we know that images typically take up the most amount of memory in a running app. So there's no point rendering a really high-resolution image onto a small little image view on a 3-inch screen. You should be downsampling that image and presenting it in the resolution that you're going to show it at. And again, Picasso and Glide help with this. They will not only downsample an image for you, they will cache that as well, so you don't have to keep doing it. We love services. Developers love services, because with services, we get to do some work in the background. We can preempt what the user might want in the morning, fetch some data, do some processing. But it's really important that our services are not long-running. You don't need a service that stays awake and active the whole time. It's actually much better to have your service wake up at appropriate times, do its work, and then shut down. Because then your app isn't basically running the whole time. If every app on your device had a service that was active, there would be no memory left for the actual foreground app. And of course, in the Settings app, you can check out what apps are causing memory pressure on your device. And I really hope that your app isn't one of those. We've tried to be really clever about giving you the right tools in Android Studio to detect memory usage. So I want to call out these two graphs here. On this side, we have a 512 meg RAM device, and on the left side, we have a 1 gig RAM device. And what I want you to focus on are those numbers on the top left. On the 512 meg RAM device, this app is using about 12 megs of memory. On this device, the same app is actually using 36 megabytes of memory, which means that this app is being really clever and using all these optimizations to adjust its memory usage based on what's available. The other thing that this tool helps us with is detect things like memory leaks. You can see our graphs go flat towards the end there, which basically means our app is allocating a bunch of memory to start with and then capping it off. We don't have leaks where this graph just grows and grows and grows. This is the shape of a graph that we should all aspire to in our apps. Battery is near and dear to everyone's heart, right? We love our devices so much that we're always complaining that we don't have enough juice, we don't have enough batteries available to do all the things that we want. And so it's made even worse when you have apps that don't address battery use appropriately. So in your own apps, what you should be doing is if you need to do some background work, coalesce it, batch it up. Don't have the device wake up frequently for you to do work. You're better off waking up once, doing a chunk of work, and then letting the device go back into standby. Even better, what we should be doing is making sure that we're not running this sort of work when the device is running on battery. We actually should be making sure that the device is connected to a power charger, that it's connected to a network that's unmetered, so we're not costing the user money. And there is an API to do this. In Android Lollipop, we introduced the Jobscheduler Api, which does exactly that. You can mandate heuristics that say, I want to be charging, I want to be on Wi-Fi, and I want to do it around this time of the day. But I know what you're saying. I don't want to just run on Lollipop. I want to support all my users. The Gcm Network Manager Api is part of Google Play Services, and it is Job Scheduler for Android 2.3 and up, for Gingerbread and up. Don't be fooled by the fact that it's called Gcm Network Manager. This is not a Google Cloud messaging API. It literally is for scheduling your jobs. And my personal favorite thing is that both these APIs help you survive reboots. So you can schedule a task, and if the user reboots their device, or they turn off their device, when they turn it back on, you can dictate that those scheduled tasks will still run without you having to reschedule them. So this is a great way to respect the user's battery. We've talked about caching quite a lot, but it's really important that we don't just run away with our cache. We don't grow forever. We do it intelligently. So we should have a strategy for caching. We should hold on to the things that are most important, as well as the things that are most frequently used. Things that are old and out of date, we should actually throw away. Now, the nice way and the easy way to do this is use Glide or Picasso that manage this for you, for your image cache. But if you're using your own cache, something custom, you definitely need a strategy in place that helps you manage it. And the reason that you need it is because of this scary notification. Storage space running out. You may have seen this yourself, that apps have taken up enough enough storage space on your device that your device is starting to run low on space. So what do? You tap the notification, and you see this dialog. This is the settings app. It sorts all the apps by the amount of space that they're taking up. Now, if your device is low on storage, and you can't take photos of your family and friends, the first thing you're going to do is start to uninstall the big, heavy apps. You really don't want your app to be one of these. You want to have a good caching strategy in mind. But I'm going to give you another tip. The Android framework actually sends out a broadcast before it gives the user that notification. That broadcast is action device storage low. And what you can do is listen for that broadcast, and at the point that you receive it, you can clear out your cache. And that means you're doing exactly what the system wants you to do. The system is saying, hey, look, I'm running out of storage. Can you please clean yourself up? And you're doing that. You're clearing out your cache. And better yet, you're trying to remove your app from being at the top of this list. So the apps that don't respond to this are more likely the ones that get uninstalled. You should go and measure the storage of your own app. The settings app does this. In fact, it breaks it down very nicely. You can see how much space your APK is taking up, how much data in the data directory, as well as your cache. So go ahead and measure it. Look at your storage space across different devices. All right, connectivity, compatibility. Let's talk about data cost. The first cost that your users incur from your app is actually at installation. And we know from research that Indian users are sensitive to APK sizes. And they're not just sensitive to the APK size when they install the app, they're just as sensitive to it when they upgrade to a new version of your app and are alarmed by just how big it's gotten. So the first thing you should do is audit your APKs. If you feel like your APK size is starting to bloat, make sure you don't have really high-resolution images in your app that are targeting low-resolution devices. You should profile your users. Use the Play Developer Console to see what type of devices are installing your app. And if you find that you still need those assets, you should consider using multi-APK. Multi-APK is a configuration in build.gradle. And the reason it's useful is that if you think about how APKs are built today, when you hit build, we compile one monolithic APK that's applicable to all these different densities, right? Multi-APK helps you split up your APK so that you end up with an APK for LDPI, MDPI, HDPI, so on and so forth. So it's a really simple build configuration. It adds a little bit of overhead for you because when you upload it to the Play Store, you have a number of APKs now that you upload. But the benefits are huge, right? Because you end up with an APK size which is much smaller and really targeted to your user's device, right? It helps you get those conversions. And you can track the growth of your APK size on your build server. We've talked about data at rest, caching. Let's talk about data in motion, right? Things that we request over a network. We really should be efficient. And there are many ways we can be efficient. A simple way is we only request the things that are visible on screen. So we saw an animated image earlier of an app. Those images were being pulled down because they were being displayed. We weren't trying to prefetch ahead of time tons and tons of images. We were being clever about it. In terms of efficiency, we also never want to request the same image from the network if we don't have to. So the first time you request it, you pull it down, you cache it. The next time you need it, you'll get it from the local cache. It's really, really important we do these things. We also want to optimize our images, right? We want our servers to send us images that are downsampled already. You don't want to have to fetch a high-resolution image from your server and downsample it locally, because that's cost to your user. You've transferred all those bytes. There's a file format that can help you called WebP. Now, I know what you're thinking. Did he say WebP? I thought it's an Android talk. Right? WebP is not just for the web. WebP is a file format that's very much relevant to mobile apps. In fact, Android has had support for WebP since Jelly Bean. And WebP results in a smaller file size than PNG or JPEG at both lossy and lossless. So it's something you really should consider. Now, when it comes to measuring our data use, Android Studio provides an excellent monitor. This is the network monitor on Android Studio, and you'll see here that our app is requesting 3 short bursts of data and then big ones, big chunky requests. This is the type of data request that you should have. There on the left, those initial ones, we requested the text that we were displaying to the users. Then we started to pull down our images. So go ahead and monitor and measure your own apps. See how they fit in with this. So that's just a taste of what's possible. India is an exciting place. The number of users coming online are exciting. The opportunity is immense and huge. So I hope today that by sharing with you the 3C framework and some ways that you can really optimize your apps for India, that you're able to be the apps that these new users want and love. With that, I'd like to invite Bapu Kota, the CTO and VP of Dailyhunt, to talk about their experience with applying this framework.
Thank you. Hi, everyone. I'm Bapu. I head engineering for Dailyhunt. I wanted to start off talking about the spread of literacy in India, the spread of local dialects in India. So as we know, India as a diverse country has 22 official languages. And of the census reported literacy of 70%, only 10% makes up for English. What that amounts to is that, like Kunal said, around 500 million mobile smartphone users consuming internet services would be engaging with these services through local language. This is our playing field. Dailyhunt is India's largest news and content platform, content ranging from ebooks to content helping with education and test prep material. Like these stats help us, so far the app has been able to manage over 110 million installs. Through the high engaging experience, it manages 3+ billion page views a month, over 28 million book downloads. And then the last statistic is very important, and that highlights the nature of consumption, the consumption pattern both in terms of users and usage on our app. So we see that more than 95% of our usage and users look to consume content and the services in local languages. At Dailyhunt, we are aspiring to be a destination that offers daily habits for our users. We wish to be the first point of internet access for the users. And towards that, we've been investing heavily in terms of not just building for scale on the back end, building services and platforms that are able to manage this larger scale in terms of reach and engagement, but also equally emphasizing on, like Ankur was detailing just now, aspects around experience, aspects around performance. I just wanted to walk you through a couple of things that were relevant given the flow of our session so far. On the localization and script support, we have within the app a rendering engine that is built on top of Android's native TTF-based rendering. And this helps us transform, compose, and render content from across 15 Indian local languages based on 12 scripts. While we look to transfer the content from our backend systems onto the app on the front end, we also do certain kinds of compacting and packing that helps us optimize the size of the content that transfers from the backend infrastructure to the front end. This eventually shows up in terms of better user performance on the app. Since we are local language focused, we also invested in tools that help non-technical workforce in helping us build an experience that is also localized. Not just the content, but also the navigation and the entire user experience. So we have tools that allow people to contribute towards translation, people to contribute towards corrections. And then the tools take care of building those translations into the APKs that eventually the users get to use. We are also very focused on managing the performance of our apps on low bandwidth networks and put a great emphasis on testing and validating our experiences on low-end devices. We believe that if we focus on creating optimal performance of the app on lower-end devices, then with better capabilities and resources on the devices, the app's performance will only be more optimal. Some of the things that we've looked to do and that have helped us include things like having different HTTP engines for text versus images versus ads. I think Kunal just walked through this one Ankur just walked through this one as well. On the images side, We have benefited tremendously by shifting from other formats of images to WebP-based images. And this has given us savings from anywhere between 30 to 80%. We also do bucketizing of images because on the news side, we have experiences focusing on news aggregation, news curation, and news personalization. Our backend systems create buckets of images as they acquire content from publishing houses. And these buckets of images get mapped depending on the device resolutions that the users own. And this has helped us in managing an optimal experience in terms of not just the size, but also the way in which the app renders itself. As far as the images go, one of the other things that we've looked to do is to manage a prioritization policy. So the images follow a last in, first out order, wherein the images on the screen take priority, and therefore the overall experience on the user side ends up being more responsive. So that's pretty much what I wanted to cover in terms of some of the things that we've attempted to do, much along the lines of what we've heard through the other sessions. We have benefited. We are continuing to invest in making our app better. We are launching features like offline mode, doing better at caching, and then allowing the user to engage with the app and consume content in the offline mode. So thank you. We look forward to having you try out the app and help us with your valuable feedback. Thanks a lot.
Thank you. All right. Thank you very much. I hope you can see why it's really important for you to optimize your apps for India. With this, I'd like to now welcome back Kunal Soni.